For centuries, humans have gazed at the stars and wondered about the origins of the universe. The question of where everything began is one of the most profound mysteries in science and philosophy. The prevailing scientific theory, known as the Big Bang Theory, suggests that the universe originated approximately 13.8 billion years ago from a single, infinitely dense point. This event marked the beginning of time, space, and matter as we understand them. However, some scientists, including the renowned physicist Brian Cox, have proposed that the universe may not have had a definitive beginning at all. Instead, it may have existed eternally in some form before the Big Bang. This idea challenges our fundamental understanding of cosmology and raises profound questions about the nature of reality, time, and existence itself. The Big Bang Theory, first proposed in the early 20th century, is widely accepted as the leading explanation for the origin of the universe. It suggests that all matter and energy were once condensed into a singularity, an infinitely small and dense point. Then, in a sudden and rapid expansion, space itself began to grow, and matter spread outward, eventually forming galaxies, stars, and planets. This theory is supported by several key pieces of evidence, including the cosmic microwave background radiation, CMB, the observed expansion of the universe, and the abundance of light elements such as hydrogen and helium. Despite its success in explaining many aspects of the universe's evolution, the Big Bang Theory does not provide answers to some fundamental questions. For example, what caused the Big Bang? What existed before it? Was there a beginning at all, or has the universe always existed in some form? These are questions that physicists and cosmologists continue to explore, and new theories have emerged that challenge the notion of the Big Bang as the absolute beginning. One of the biggest problems with the traditional Big Bang model is the singularity itself. A singularity is a point where physical laws break down, and our current understanding of physics, particularly Einstein's general relativity, cannot explain what happens at this point. In other words, our theories fail to describe the state of the universe at the very moment of its supposed birth. This has led some scientists to question whether the Big Bang was truly the beginning or if it was merely a transition from one state to another. Brian Cox, among other physicists, has suggested that the universe may not have had a beginning in the conventional sense. Instead, it might be part of an eternal, cyclical process, or it could have existed in some other state before the Big Bang occurred. Several alternative theories support this idea, each offering a different perspective on what might have preceded the Big Bang. One such theory is the cyclic universe model. This theory proposes that the universe undergoes endless cycles of expansion and contraction. Instead of having a single beginning, the universe repeatedly goes through phases where it expands, reaches a maximum size, and then contracts back into a singularity, only to begin the process again with a new Big Bang. This idea has roots in ancient philosophical and religious traditions, which describe cosmic cycles of creation and destruction. Modern versions of the cyclic universe model are supported by certain aspects of string theory and quantum mechanics, which suggest that the universe could experience periodic rebirths. Another theory that challenges the notion of a singular beginning is the idea of a pre-Big Bang universe. Some physicists propose that our universe emerged from a previous state of existence, which could have been another universe or a quantum vacuum. According to quantum mechanics, even in what we consider to be empty space, virtual particles constantly pop in and out of existence due to quantum fluctuations. Some scientists suggest that our universe could have arisen from a similar quantum fluctuation in a pre-existing vacuum state. This idea aligns with the concept of eternal inflation, which suggests that our universe is just one of many bubbles in an infinite multiverse, each forming from different quantum fluctuations. The idea of an eternal universe also raises philosophical and existential questions. If the universe has always existed in some form, does that mean time itself is infinite? If there was no true beginning, then what does this imply about causality and the nature of existence? The human mind is accustomed to thinking in terms of beginnings and endings, but the possibility of an eternal cosmos challenges these deeply ingrained concepts. Some philosophers and scientists argue that the universe could be fundamentally timeless, existing in a way that transcends our understanding of past, present, and future. Interestingly, the notion of an eternal universe has historical precedent. Ancient civilizations such as the Hindus, Buddhists, and Greeks conceived of the cosmos as an eternal, cyclical system. Hindu cosmology, for example, describes the universe as going through endless cycles of creation, preservation, and destruction. Similarly, the ancient Greek philosopher Heraclitus proposed that the universe is in a constant state of flux, with no ultimate beginning or end. These ancient ideas bear striking similarities to modern cyclic universe theories, suggesting that humanity has long grappled with the possibility of an eternal cosmos. Recent scientific discoveries have provided tantalizing clues that could support the idea of a pre-Big Bang universe. One of the most intriguing pieces of evidence comes from anomalies in the cosmic microwave background radiation, CMB. The CMB is the afterglow of the Big Bang, providing a snapshot of the universe when it was just 380,000 years old. However, certain irregularities in the CMB, such as the so-called cold spot, have puzzled scientists. Some researchers, including Nobel laureate Roger Penrose, have suggested that these anomalies could be remnants of a previous universe, possibly the final traces of black holes from a past cosmic cycle. Another fascinating avenue of research involves black holes. According to Stephen Hawking's work on black hole radiation, black holes slowly lose mass over time and eventually evaporate. If the universe is cyclic, it is possible that some black holes from a previous cosmic era could have survived the collapse of a previous universe and carried over into our own. If such ancient black holes exist, they could provide direct evidence of a pre-Big Bang universe. The study of quantum gravity, a field that seeks to unify quantum mechanics and general relativity, may eventually provide answers to the question of what existed before the Big Bang. One promising theory in this area is loop quantum cosmology, which suggests that the universe never truly reaches a singularity but instead undergoes a bounce, where it contracts to a very small state before expanding again. This model eliminates the need for a true beginning and replaces it with a cyclical process, in which the Big Bang was simply a rebound from a prior contraction phase. If the universe has always existed, it raises profound questions about the nature of time, existence, and even consciousness. Could intelligence or life have existed in previous cosmic cycles? Could there be remnants of past universes hidden in the fabric of reality? If time is infinite, does that mean everything that has ever happened was inevitable? These are questions that scientists and philosophers continue to explore, and their answers could reshape our understanding of the universe and our place within it. Ultimately, the question of whether the universe had a beginning remains one of the greatest mysteries of modern science. While the Big Bang theory provides a compelling explanation for the observable universe, it does not necessarily mean that it was the first event in all of existence. Theories of cyclic universes, quantum fluctuations, and eternal inflation suggest that the cosmos may have a far deeper and more complex history than we currently understand. As our knowledge of physics advances, new discoveries may one day reveal the true nature of our universe's past, whether it had a beginning or has always been. Brian Cox and other scientists who explore these ideas challenge us to think beyond traditional cosmological models and consider possibilities that extend beyond human intuition. If the universe is eternal, then our existence is part of an unbroken chain of events stretching infinitely in both directions. This perspective not only changes how we view the cosmos but also deepens our appreciation for the mysteries that still lie ahead in our quest to understand reality.